And so in this video, we're going to refactor one of our coding examples to use a list instead of an array. Remembering that arrays are in every programming language that you'll ever study, and this lists are just kind of like the evolution of an array. It's like a newer array. So just like an array, a list has a data type. And so let's just do the last one that we did with our painting demo, where we had these rooms, and here we have an array that stores a bunch of room objects. And a list, a C# list is, we could have a list of rooms like this, right? So here's a list of rooms, here's an array of rooms. And so it's the same concept. It's just a storage structure to store your data. Lists are mostly popular because when you read data from a database, most of the time you're reading it into a list. And the way that lists typically work is there are methods, right? So one way of adding your first room here is rooms, which is my identifier, add new room. And we could say 10, 10, and 10. Okay, so this is calling this add method. This would be equivalent, this add call would be equivalent of saying my home room sub 13 equals new room, right? So like that. So this is adding one room at a time, and you could say rooms.add, and now we have a list of rooms that has 4 different rooms in it. Obviously they could all have different dimensions. Okay, but just like arrays, there's this array initializer. Well, you could do the same thing with the list. There's a list initializer. And so instead of calling this add method a bunch of times, we can have a list initializer like this, say new room, and boy, doesn't that look similar? We have a list of rooms versus an array of rooms. If we're literally, we can copy this and paste it right here. Put a semicolon in, and we've refactored our code from using arrays to a newer storage unit. Okay, a list is, they call it a C# collection because it can store a bunch of things. Okay, so let's refactor this, right? And that same for each loop, instead of looping through that, let's just call this, because we're at Rankin rooms. Okay, so I have my list identifier is called Rankin rooms, full of data, and let's loop through for each room in Rankin rooms. Let's call the toString. And we have refactored our code. Okay, so don't let lists scare you. Literally, the syntax between an array of rooms and a list of rooms is very similar. You could have a list of integers. You put the data type in these brackets called my numbers is a new list of ints. And you say my numbers dot add. But it is strictly typed. And notice if I try and add a string, 100. That doesn't work because this is a list of ints, not a list of strings. So lists are strongly typed like everything else. You just put the data type in the angle brackets. This little piece right here is called a generic. So this class can accept a data type in these angle brackets. Again, this is called the C# generic type. A list is a generic type in that it can have many different kinds of lists. Remembering, let's see, my numbers dot, there's a capacity, which again, we did do a lecture on a list. The capacity is the number of elements. In this case, my numbers dot capacity, well, is 2. There's capacity, and then there's also, if I kind of scroll, there's a difference between capacity and, let me find, count. Count is the number of elements. Capacity is the default, how many elements does it store, right? So in this case, count is 2. Capacity, I think the default is 4. Capacity is, I want to say is 4, until you put a 5th element in it, the capacity doubles to 8, then it doubles to 16, right? So the capacity is doubled as soon as the count goes above the capacity doubles. So if you're making a normal for loop, you loop through my numbers dot count. You don't loop through capacity, you loop over the count. So that's creating a loop of 2 iterations. Okay, so just to show a quick one on how to refactor your code from an array of things, an array of objects, into a list of objects.